So your new form, that will be omega t. So you can write it like that, locally, condition. And this gives a condition, that gives you a deformation. So you have a quadric. In this way, this coefficient, so in this way, this gives you a quadric, describing local variations, and then you can kind of. So because of this, so this here we have quadric, and here we have something like degree n plus 1, which tells you that this actually is run by, so everything, instead of having a complicated degree n equation, we are getting a quadric, which is, I thought it was simply impossible because but it happens but it happens. And that's exactly happens when you have, for example, symmetric power of Hessian.
Which one is quadric? Quadric second term in the
Yeah, so this is a deformation, quadric deformation. So here you have very easy, see that this is quadric. So you have on the one hand, the variations give you quadric, and you know that the solutions, that the points, the local points on the quadric correspond to solution. On the other hand, the cosmological condition is a form of high degree. One is the power of another. So that's already a topological condition on such variety, which is quite non-trivial. And actually, it was later kind of the whole structure of this subring generated by H2 was described by Verbitsky. Then I gave a simplified version of this. But that's already quite remarkable. So this is the main, was the main point when the form, this form Q appears. Sorry, that was actually kind of deviation. Okay, so that was kind of deviation. But I wanted to introduce this form.
And which kind of object, Q of x? Is it in H2 of x?
So Q of x is a form which maps, so in fact, so it's just a one-dimensional form, it's just a quadratic form.
Where?
On H2. On H2 of x.
And it
Have a
takes
map,
value?
Q to H2.
It is comes from what, Hermitian forms?
No, it's just extra, no. No, it is just a form on H2. You have a particular kind of, you end up in a particular area.
It takes value in H2.
To H2 of x, yeah.
Rational value.
Sorry?
Rational value.
Rational. So it's integer form, you get from here something like that. And this governs everything. So this governs all the topology. So this one form which kind of responsible for most of the effects. Okay, that's very particular property, topological property of such method. The existence that everything, all this kind of, so all the structure, so maybe I should say, so topological property, all the structure of subring, of a subring in H star of x. I would say Q for simplicity, maybe. Because I'm omitting potential finite elements or finite or something. Is governed, is in subring in H2 generated by H2 x is governed
And is there a relation between Q of x and x squared? If I take x squared, I will also go somewhere to x to H4.
well, no.
No relation.
No. X squared, there are many x squared. Look, maybe I shall write the way it, how to say, what does it mean governor? There is this Q, and then you have, so you have H2, you have kind of S2, H2, and so on, and then from Sn H2, you divide by ideal Q of X. And I think, and so on, and then so how to say, it is self-dual subring, like so, almost like symmetric matrices. So it's a free symmetric product up to the middle, and then you start canceling Q. So Q by H2 by H2 and Q by that, and so on. So just in the middle somewhere, you are getting. You are starting getting diminishing spaces. So Q is like a relation there. Q to the power. yeah. I think Q in the power.
Q is also non-degenerate, right?
Q, well, it's an element. It's
Q
just
of
an
X.
element.
Yeah.
It's just an element in H22. Yeah. So we don't. No. Q is not a particular. How to say, is not given by a particular class. It has many representatives. Q is basically correspond. Maybe I didn't want to touch it to C2 of X. That is the relation. Second Chern class is always non-trivial. It is always in some kind of positive cone in H22. Yes, and this is so basically Q or C2. And their properties are telling everything about topology. That's Hitchin, Witten, Rajansky. So that's a completely different line of thought. So this is a very big area by now. There is an approach from the point of view of metric geometry, and there is another approach from symplectic and so I didn't want to touch actually Witten, Rajansky, and what Hitchin and Seven did there. So the whole classification reduces to the structure of this bond, its powers and so on. Topologies get coming from there. Okay, let me get back on track. Where did I? So maybe I will recommend you. So Q actually appeared in the deformation theory. That was so. What it says is that there is a quadric Q in e to the power m. Let's say so any. So now we have any x. So before we had this series of x, but now we have any x. So now we have Q. This is a integer, so in projective space, which is projectivization of H2 of X. Projectivization of H2 of X C. Inside here we have H2 of X Z, integer lattice. But then we have a quadric inside here, such that W, Q of X, Q of so, and this is exactly this given by Q. That's a quadric. That's a yeah. So this map into one. So we map into one into Q. Okay, so we have Q of V equal to 0. Is exactly corresponds to classes which are potentially Vt, that means Vt to 0 on xt, on variation of xt. So this quadrant describes all the classes which can appear and which in fact appear in the neighborhood first. as forms, as the classes which can be represented by holomorphic form on some deformation of X. This is given by